Okay, this is going to be the problems that are in chapter 9 for chemistry, and I'm just going to include the problems. The other questions you can easily find the answers in your textbook. So this will just include the problems. So that means that we are going to start with number 12. So again, this is chapter 9, starting with number 12. And number 12 says that we are going to make a solution by dissolving 100 grams of lithium sulfate into enough water to make 325.0 milliliters of solution. What is the concentration in moles per liter? Okay, so what they're really asking us for then is molarity, because molarity is moles per liter, and that is equal to moles divided by liters. Okay, so we don't have moles of lithium sulfate, but we have enough information to figure that out. And then in terms of liters, we were given milliliters, and we can easily convert that to liters by dividing by 1,000. Or moving the decimal place 3 places to the left. So that would make our volume 0.3250 liters with a capital L. Okay, so then it just becomes converting this lithium sulfate from grams into moles. So we have 100.0 grams of lithium sulfate, and we want to convert that to moles, so moles is going to go on top. How many moles? 1 mole is equal to how many grams? Okay, so we have 1 lithium, 1 sulfur, and 4 oxygens. So the lithium is 6.94. The sulfur is 32.06. Getting these from the periodic chart. And then we have 4 oxygens, and each oxygen is going to be 16.00. So if we add all of those together, we will find that lithium sulfate has 109.94 grams in a mole. Okay, so we're just going to put that 109.94 here. Okay, so grams will cancel. A gram on the top and a gram on the bottom. That's going to give us the number of moles. And so what we end up with is 0.32. Oh, no, never mind. That's wrong. You end up with 0.9096 moles of lithium sulfate. So then all we have to do is put that in this equation up here for molarity, 0.9096 moles. Okay, so now we have moles per liter. So the molarity comes out to be 2.799 moles over liters, moles per liter. Okay, 2.799 moles per liter. Okay, that's number 12. Okay, the next one we will do is number 13. And number 13 says that we want to make 225 0.0 milliliters of a 4.5 molar solution of sodium hydroxide. How many grams of sodium hydroxide will be needed? Okay, so in this case, we're given the molarity and we're given the volume. So with that information, we can determine the number of moles of sodium hydroxide. Once we have the number of moles, then we can use the periodic chart and we can determine the number of grams. Okay, so molarity is equal to moles divided by liters. Okay, so we want to solve for moles. So we're going to multiply both sides by liters. Okay, so liters cancel over here. So then what we have is that liters times molarity will give us moles. Okay, so the liters, 225 milliliters divided by 1,000 to get that into liters. So it's going to be 0.2250 liters. And we will multiply that times the molarity, which is 4.5. And the units there are moles per liter. Okay, so liters are going to cancel. You'll be left with moles. And what you will end up with in terms of moles is that you will get 1.00 moles, I think. 4.5 times 0.2250 will give us one, with two significant figures, is going to give us 1.0 moles of sodium hydroxide. Okay, so now we just convert that to grams. So 1.0 moles of sodium hydroxide, and we need to know, we're going to convert that to grams, so grams is going to go on top and moles will go on the bottom. So 1 mole for sodium hydroxide, we have 1 sodium, 1 oxygen, and 1 hydrogen. So the oxygen is 16.00, the hydrogen is 1.01, and the sodium is 35.45, I believe. No, 22.99. 22.99. Okay, so adding those all together, you get that there's 40 grams, 40.00 grams in 1 mole. Okay, so I'm going to just put that 40.0 grams up there. So 1 times 40 is going to give us 40. So, and we can only have two significant figures. So I guess we'd have to go 4.0 times 10 to the 1 grams. Okay, so that is our answer for number 13. Okay, the next one we will do will be number 14. And number 14 gives us this equation. Okay, so that's the equation we are given, and now let's look at what we are given. For sodium hydroxide, so this, the sodium hydroxide, we are told that you have 167.4 milliliters, and it is a 1.39 molar solution. There's an excess of this, so we don't, that means that they're just telling us we have enough for the reaction to run. That's not going to be the limiting reactant. And then the question we are asked is how many grams of this? Okay, so when we are told something about one thing in the equation and asked to find something about another thing in the equation, that means we're going to be using stoichiometry. And in order to use stoichiometry, we have to have it in moles. So we have enough information here to determine the number of moles of sodium hydroxide. Using that information, we can determine the moles of this cobalt hydroxide. And then once we have the moles of that, we can convert it to grams. Okay, so let's start with the sodium hydroxide. So molarity is equal to moles over liters. We're going to solve for the moles. So again, we just did this. We're going to multiply both sides times liters to get rid of the liters on that side. So molarity times 0 times liters is going to give us moles. So the molarity was 1.39 moles per liter times the number of liters, 167.4 milliliters is 0.1674 liters. Okay, so liters are going to cancel, and you'll be left with number of moles. And what you will get is with three significant figures, you will get 0.233 moles of sodium hydroxide. Okay, now that that is in moles, we can use that to determine the number of moles of this. Okay, so 0.233 moles of sodium hydroxide. And there is one of the cobalt hydroxide for each 2 sodium hydroxides. Okay, so basically it's going to be 0.233 divided by 2. So that will give us, so the sodium hydroxides are going to cancel. You'll be left with moles of this. So the answer is 0.117 moles of cobalt hydroxide. Okay, now that we know that, we can convert it to grams. We want grams on top, so how many grams is in a mole for cobalt hydroxide? So there's 1 cobalt, 2 oxygens, and 2 hydrogens. Okay, so 2 times 16 for the oxygen, 2 times 1.01 for the hydrogens, and then cobalt, I don't know that one. Cobalt is number 27, it's 58.93. So adding all those together, we get that there are 92.95 for cobalt hydroxide, 92.95 grams in a mole. Okay, so we put that number up here, 92.95 grams in a mole. Do the multiplication, 0.117 times 92.95. So moles are going to cancel here, and your answer will be in grams. So what you will get with 3 significant figures, you should get 10.9 grams of the cobalt hydroxide. Okay, that's our answer. That's what we were asked to solve for right there. Okay, next we will do number 15. Okay, so number 15 tells us that, so again, we're given a formula. Okay, so there's our chemical reaction, and we're told that we have an excess of this, so that's just telling us that that's not going to be the limiting reaction. And we're told that we want to make 150 grams of this. And if we have a 2.56 molar solution of this, then what volume will be needed? Okay, so again, we are given some information about the barium carbonate, but we are asked to find something about the barium nitrate. So we'll start with what we know. We want to end up with 150 grams of the BaCO3. We've got to get that in moles because we can't, for it to use stoichiometry, it has to be in moles. So you have 1 barium, 1 carbon, and 3 oxygens. So the carbon is 12.01. Each of the oxygens is 16. And the barium is number 56, and it is 137.33. So adding those all together will give us 197.34 grams per mole. Okay, so I'm going to go ahead and erase this so I can free up some room here. So we can convert these grams now to moles. So 1 mole is 197.34 grams. Okay, so grams are going to cancel, and we will have moles of barium carbonate, and the number of moles for that would be 0.7601. Okay, now because that is in moles, we can use stoichiometry to get the moles of this. Okay, so we have let me erase this. We have 0.7601 moles of BaCO3, and there's not numbers in front of either one of these two that we're interested in, so that means they're both 1. So there is 1 BaNO3 that goes on top because that's the one we're solving for each 1 BaCO3. Okay, so the BaCO3s cancel. Times 1 divided by 1 is just going to be the same number, so 0.7601 moles of BaNO3. Okay, now we have the number of moles and we have the molarity, so we can solve for volume. So molarity is equal to moles divided by volume. So if we just do our algebra, multiply both sides by volume, and then divide both sides by molarity, that will give us that V is equal to moles over molarity. Okay, so we just solved for the moles. It's 0.7601 moles. And the molarity was given to us as 2.56 molar, which is the same as moles over liters. So moles cancel, and your units that you're left with is liters, so that the volume that you will get with 3 significant figures, because this will limit us to 3 significant figures, is going to be 0.297 liters. Okay, that's it for number 15. The next one we will do will be number 17. So the other way, besides molarity, the other way that we express concentration is molality. And number 17 says that we have 67.8 grams of KCl and 450 grams of water. What is the molality? Okay, so molality, which is a lowercase m, is moles divided by kilograms. Okay, so we need to get moles with this. So 67.8 grams of KCl, and we want to convert to moles, so moles is going to go on top and grams on the bottom. So we have 1 K and 1 chlorine. So the potassium is 39.10 and the chlorine is 35.45. So adding those together, 74.55 grams is 1 mole. Okay, so I'll put the 74.55 up here. Okay, grams are going to cancel. And with 3 significant figures then, we have 0.909 moles of KCl. Okay, now we can go ahead and plug our numbers into the molality formula. The moles is 0.909 moles, and we're given this in grams, so we can convert that to kilograms by dividing by 1,000 or moving the decimal place 3 places to the left. So it's going to be 0.4500 kilograms. So molality, if we do that math, will come out to 2 0.02 moles over kilograms. So that's our answer for number 17. Okay, number 18, I think is we're going to do 18. Yeah, number 18. A chemist wants to make a 2.34 molal solution by mixing 23.1 grams of magnesium chloride. How many kilograms of water will need to be used? Okay, so as soon as you see that kilogram and this, so we're dealing with the molality concentration, the molality way of expressing concentration. So molality is equal to moles divided by kilograms. Okay, so we can go ahead and convert this 23.1 grams into kilograms by, I'm sorry, no, I'm sorry. We're solving for the kilograms. So let's go ahead and do that. So we're going to multiply both sides times kilograms. And then divide both sides by the molality. So kilograms, which is what we were asked to find, is equal to moles divided by molality. Okay, so we're given the molality as 2.34. So 2.34, and that's moles over kilograms. Okay, so the only thing we need then is to figure out how many moles of the magnesium chloride we have. So we have 23.1 grams of magnesium chloride. We can convert that to moles. So we're going 2 moles, so moles will go on top and grams on the bottom. So we have 1 magnesium and 2 chlorines. So the magnesium is 24.31 and the chlorines, 2 of them, 35.45. Okay, so adding all that together, you get 95.21 grams in a mole. Okay, so I'll put the 95.21 here. So the grams are going to cancel. And 23 divided by 95.21 will give us 0.243 moles. Okay, so now we can plug that into this formula here. 0.243 moles. So kilograms, if we do that math, 0.243 divided by 2.34 gives us 0.104 kilograms of water. Okay, so that's the answer to the question that we were asked, number 18. Okay, next we will do number 19. Okay, number 19 tells us solutions are made from water and the following solutes. So we're going to make 1, 2, 3, 4, 5, 6 different solid solutions. Okay, and here's what this question says. It says the molalities of the solutions are all the same. So which would have the lowest freezing point? So we need to look at delta T is equal to negative I times K times M. So looking at that, and this would be the K of freezing, it's all water. So we are told that the molality is the same for all 6 solutions. The solutions are made with water, so K is going to be the same. So the thing that will affect the freezing point is really going to be I. And so we have to look at the I for each one. So we have to look at how many ions each of these will split into. Okay, so this one, I would be equal to 3. So you have 2 of the nitrate ions and 1 magnesium. This one, I would also be equal to 3. 2 chlorines and 1 calcium. The sodium chloride, I is going to be equal to 2. NH3 is a covalent compound, so it won't split into ions, so I is going to be equal to 1. The NH4, 2, CO3, so here's 2 ions, so it's 2 of those and 1 of those. So I is going to be equal to 3. And then for this one, you're going to have 1 aluminum and 3 chlorines. So I is going to be equal to 4. So the I that would make this number the biggest and therefore have the lowest freezing point would be an I of 4, which belongs to the aluminum chloride. Okay, AlCl3, because it's going to break into 4 ions. Okay, number 20. Number 20 says, what is the freezing point of a solution that is made by mixing 32 grams of sodium chloride with 250 grams of water? Okay, so you know that, you know the formula for freezing point, delta T is equal to negative I times K times molality. And we are given K as 1.86 degrees C over molality. So we can figure out what's I, sodium chloride, so I is going to be 2. So right now we have negative T, we have delta T is equal to negative 2 times 1.86 degrees C over M. And then we have to have the molality, and we can calculate molality because we have the number of grams. So molality, lowercase m, is moles divided by kilograms. Okay, so the kilograms would be this number divided by 1,000. So kilograms is going to be 0.2500 kilograms. Now let's figure out moles. So we have 32 grams of sodium chloride. We want to convert to moles, so moles will go on top. 1 mole is equal to how many grams? So we have 1 sodium and 1 chlorine. So the sodium is 22.99 and the chlorine is 35.45. So adding those together, you should get 58.44 grams in a mole. Okay, so let's plug that in here. 58.44 grams is a mole. So 32 divided by 58.44 will give us 0.548 moles. Okay, so now that we know that, we can put that in our formula for molality. So 0.548 moles. Okay, so you're going to have moles per kilogram. So molality, which is lowercase m, will give us with 3 significant figures, 2.19 molality. Okay, so now all we have to do with that then is plug that into our formula. It's the last unknown for our delta T. So we're just plugging in the m here. And we said that that was 2.19 m. Okay, so the m's are going to cancel, and you'll be left with degrees C, which is what you should have for a change in temperature. So -2 times 1.86 times 2.19 will give us -8.15 degrees C. So since the freezing point of water is 0 degrees, then the freezing point of our solution would be 8.15 degrees lower than that. So the freezing point would be -8.15 degrees C. For that sodium chloride solution. Okay, that was number 20. We got 2 more. Hang with me. Number 21. A solution made from water and N2H4 has a freezing point of -1.5 degrees C. What is the molality? And again, we are told K. So K of freezing is equal to 1.86 degrees C over M for water. Okay, so for that one, we are just asked to find M. So delta T is equal to I times K times M. And we are asked to solve for M. So basically you're just going to take delta T and divide by I and K to get M. Okay, so I just did the algebra on that equation. Okay, so delta T we were given as negative 1.5 degrees C. I, what is I? Okay, so this is N2H4 is a covalent, so it will just, it won't split into individual ions, it will just stay as a molecule. So I is 1, so negative 1, and then we were given K as 1.86 degrees C over M. Okay, so now degrees C are going to cancel and you'll be left with M. And what you will get for M, if you do that math, is 0.81 with two significant figures, M, or moles over kilograms. Okay, number 22. And this will be the last one we do. I'm not going to expect you to do number 23. Okay, what is the boiling point of the solution in number 20? Okay, so for boiling, delta T is equal to I times the K of boiling times M. So we got to go back up to number 20, and in number 20 it was sodium chloride, and so I for sodium chloride would be equal to 2. Kb we're given as 0.512 degrees C over M. So then we just need to look back to question number 20 and see what we got for the molality. I gotta go back and look at that. So number 20, we calculated the molality as 2.19. Okay, so now we have everything. We just have to plug it into the formula. So delta T, so the change in temperature will be I, which we said was 2, times Kb, which is 0.512 degrees C over M. And then the molality was 2.19 lowercase m. Okay, so the lowercase m's are going to cancel. You'll be left with degrees C. So delta T is equal to 2.24 degrees C. Okay, so that's the change in temperature. So what this means is that the boiling point of the solution will be 2.24 degrees higher than the boiling point of water. So the normal boiling point of water is 100, and so we're going to add to that 2.24 degrees C, so that the new boiling point would be 102.24 degrees C. Okay, so that is the last problem that you will be responsible for knowing how to do for Module 9.